This video is going to describe how we can take the information given to us from a graph and actually determine the quadratic function from the graph. First, we have to realize that we have to start with the vertex point form of the graph. In here, you have to be able to identify that the h and k actually are the points of the vertex, and the x and y are just points on the graph. This is important to distinguish right off the start. So if I was to look at this, a good way to set this up is to actually write down the information that we know. Right here, this point up here is my vertex, and the 3 stands for the h, the 1 stands for the k, and this is just the point that's on the graph with the xy. Now we're going to break this down into slower steps so we can actually see how things are going in. The first thing we're doing, I'm going to just going to rewrite this again so it's less cluttered. And I'm going to put in the points for my vertex first. Okay, the vertex up here is saying that the h value is 3, the k value is 1. So if I was to put it in, here's the 3, keeping in mind it's negative. So this actually means that the h value always comes in as the opposite sign of what it is in the vertex, with the squared and plus the 1. So now I've put the vertex in. The next step is to actually go and put that point into this equation. Now the point is 5, negative 7. So the x value over here is the 5. The y value is the negative 7. It's important you get those in the right spot, otherwise the question falls apart. And now we just put in all the other information that's around that. Now you can see there's only one unknown that I have in this whole equation, is the a. I have to solve for this value of a and then use it back in the original equation. So now I just have some simple math to do. The negative 7 is going to stay. The a is here, and this comes to be 2 squared plus 1. Now we should know that 2 squared is 4, and coefficients usually come in front of the variable, so I'm going to say that this whole thing here simplifies to 4a plus 1 equals negative 7. Now we just got to solve for a, so I'm going to take 1 away from both sides, and I have negative 8 equals 4a. Last step, divide out that 4, and I'm going to get negative 2 equals a. Now this is not the final answer. The final answer now says I better go to my vertex form again, which was up here. And what I had was y equals a x minus 3 all squared plus 1. This has the vertex in there, and that's an important piece of information on any parabola. Now the next thing we got to do is just put in that a value that we just found. So it's going to be y equals negative 2, because that's what we found a to be, x minus 3 all squared plus 1. And this is the equation to the quadratic graph just above here. It's important that you check your answer for reasonableness. We can see right now that since this leading coefficient of the equation we stated is negative 2, my parabola should be opening down, and it is, so that's a good indication. And then just check again, do a quick check to make sure that this negative 3 and 1 is actually representing our vertex, and it is 3, 1. So this is the quadratic equation to that graph.